Hey everybody, welcome. Red Cross Elementary 6th grade science teacher Scott Johnson coming to you live this afternoon from our classroom with our special guest Nolan. Nolan, can you say hi to the people at home? There you go. Don't get too excited, okay? All right, so today we want to talk to you about oxygen. Now, oxygen, found on the periodic table, it has an atomic number of 8. It has an atomic mass of 15 and 999 thousandths. Here in this lab, we round that off to an atomic mass of 16. Now remember, that atomic number tells you the number of protons found in an atom of oxygen. That atomic mass tells you the protons and the neutrons packed tightly together in the center. What do we call that? That's right, the nucleus of the atom. And of course, the electrons are buzzing all around the outside. But what the people at home, Nolan, may not know is that oxygen hates to be lonely. It doesn't like to be lonely at all. Do you like to be lonely? No, no one likes. So we're all kind of like oxygen in that way. We really don't kind of dig being by ourselves. Oxygen actually gives us all kinds of examples of this in our everyday lives. O2, which is the kind of air that we breathe, well, that's oxygen immediately finding another buddy of its kind and just bonding together. That makes an oxygen molecule, which helps us to breathe and survive. And then, let's try that. Try to make a big breath in. Now breathe out. And see, even when we breathe out, oxygen finds other friends because it bonds with carbon, and that makes CO2, carbon dioxide, right? We also see that if we go high into the atmosphere, we get O3, which is ozone layer, right? But that type of oxygen, that's too powerful. 3 oxygen atoms bonded together, that makes O3, and that's way too much friction, too much heat. That can actually melt our lungs if we try to breathe that without a special apparatus. We also see a very safe form where oxygen makes a bond, and that's in H2O. 2 hydrogen atoms, 1 oxygen atom, and that makes water, right? I like water. Do you like water? Oh yeah, it's good for you. And it's good to have it. Once again, that's oxygen making friends with 2 hydrogen atoms. But then we have the star of today's show, and that's H2O2. That's right, we took that same water, we bonded 1 more oxygen atom to it, and that gave us 2 hydrogens, 2 oxygens, and that makes hydrogen peroxide. Now, hydrogen peroxide, it can be used to clean cuts, clean scrapes. It can even be used to clean clothes, right? Hydrogen peroxide is used for a lot of things. But today, we're going to introduce a catalyst to that. Can you say catalyst?
Catalyst.
Yeah, there you go. A catalyst is a substance that speeds up a chemical reaction. If we tried to do this without a catalyst, Nolan, this reaction could take hours. But with the catalyst that we're going to introduce today, the instant yeast is what we're going to use as a catalyst. It's going to speed this reaction way up. That catalyst, right here, say it again, catalyst.
Catalyst.
You're getting good at that. This catalyst is going to speed up the oxygen, and what it's going to do, it's going to cause one of these oxygen atoms to rip away. And now you're going to have water left behind in this little oxygen atom. But oxygen hates to be lonely, right? So it's immediately going to try to get away. It's going to try to find a friend. It's going to run as fast as it can. But that's when we're going to introduce the substance to catch it before it can get away. And that is dish soap. Okay? And it's going to create the fuzzy, foamy bubbles of elephant toothpaste. Do you brush elephants' teeth? What? Do you think elephants need to brush their teeth? What? No. I don't know. Lots of things need to brush their teeth. But this elephant toothpaste is not actually used for that. But it is given that name because kind of the size of the suds that it makes. See, before this oxygen can get away, it gets trapped inside of the soap. And that creates a large foamy mass of matter and gas. And the star of that show, of course, being oxygen. Now, Nolan, this oxygen is going to try to get away really fast. And there's going to be millions of oxygen atoms trying to get away. And they're all going to be bumping into each other. Can you do me a favor? Put your hands together like this. Now rub them together really fast. Yeah, now put them against your cheeks. How does that feel? Does that feel warm?
It feels warm.
It does feel warm, doesn't it? And that's because of friction. And we're going to create that same friction because all these oxygen atoms are going to hit each other, they're going to rub against each other, and they're going to make heat. So the first thing we got to do, Nolan, is we got to put some dishwashing liquid in to get to capture all of our oxygen. This one is Nolan's beaker. This one is mine. Nolan, what color did we use here? Why did we use green? Because green's your favorite color. And of course we used red because red is mine. Ready, Nolan? Let's put a little bit of dish soap in yours. Is that enough?
Yeah.
You say when?
When?
Okay. And let's put a little bit of dish soap in mine. Ow! You bumped my arm. And when? Okay. So now we're going to mix that. We've got just some hydrogen peroxide and food coloring in here. And now we've got dishwashing soap. In these little mixtures, we've got yeast and warm water. So Nolan, this one's yours. This one's mine. If you would, get up on your knees here. Okay, I'm going to scoot you nice and close. Nolan, we're going to take these and we're just going to pour them right into our jar. I'm going to pour mine into mine. You pour yours into yours, okay? 1, 2, and 3.
Oh, no.
Here it comes. And so we see a reaction. We see the foam start to push up. Now we used a low amount of hydrogen peroxide and a low amount of yeast to kind of keep this from going. One of the nice things you see here, of course, is it's starting to meet in the middle. It's almost like a little Christmas light display. Now you guys, we're going to give you a higher concentration of hydrogen peroxide. We're going to give you a higher concentration of fresh yeast. And for you all, as you start to see as the foam continues to collect and grow, well, you better stop it before it overflows. I can't wait to see what you all create in class today. Elephant toothpaste. Let's see how big of a reaction you can make yourself. Nolan, let the people know. Say, have a great day.
All right.